Hi class, just a quick video to answer some questions about what's going on in figure 710. This is on page 200 of your textbook, and there was a question about what do all these red arrows mean and how do you interpret what's going on with air pressure and wind. So before we jump into the craziness of these two figures, let's first look at what our global circulation pattern on Earth would be with no land masses. And hopefully you guys are all pretty familiar with this. We know we've got these bands of highs in the subtropical region, and then the poles, which is areas of descending air, that's stable air, and then we have these lows like the equatorial low, the intertropical convergence zone, and the subpolar lows that are areas of rising air which create low pressure. So in an idealized planet we have these nice bands, right? But when we add continents and we start to add differential heating of land and water, we end up creating these semi-permanent high and low pressure cells with circulation patterns. So we have these subtropical highs that are anticyclonic circulation patterns. In the northern hemisphere they move clockwise, and in the southern hemisphere they move counterclockwise, so these are anticyclones. And you'll see as we look at the different seasonal patterns, those subtropical highs stick around. They're often there. And so what happens is with the seasons, the heating and cooling on different parts of the planet it varies, and so what happens is these highs and lows, these air pressure cells, strengthen and they move around. So their location changes and their strength changes with the season. So that's why we can't say they're permanent, they're semi-permanent, because they move and change with the seasons. And it depends on where there is more or less solar heating. So let's look at figure 710. So now we're looking at January, right? So this is winter in the northern hemisphere. So the northern hemisphere is colder, and the southern hemisphere is experiencing summertime, so it's warmer. And some interesting things to note in the winter is we have this really strong Siberian high pressure that sets up because the continent here gets really cold in the winter. Siberia, of course, is really cold, so it gets cold. We have descending air here, so we have a high pressure system, and in the northern hemisphere that is clockwise anticyclonic movement, right? The red arrows are showing the direction of the surface winds. So they're moving from high pressure, we have 1,032 millibars here, outward towards the lower pressure, but because of the Coriolis effect, it's curving around and moving in a clockwise pattern in the northern hemisphere. We also have two other highs in the northern hemisphere, the Pacific high and the Azores high. Those are those subtropical highs that we're going to see whether it's July or January. And again, in the northern hemisphere, what direction do they go? Clockwise, right? And again, the air is flowing from high pressure. Here we have 1020 out towards lower pressure. What direction would a high move in the southern hemisphere? Well, it's going to move the opposite direction. It's going to go counterclockwise. And a high, remember, is descending air. High pressure here, 1,020 millibars, so the air is moving away from that high and moving in a counterclockwise pattern. And again, these are our subtropical highs in the southern hemisphere down here. Another thing to notice in the January chart is we have a couple of lows that develop in the northern hemisphere. And remember, low pressure means rising air. In the northern hemisphere, they move counterclockwise, and these are what we call cyclones, right? So a low pressure turns counterclockwise. And notice the numbers on the isobars, they're lower at the center where these L's are, right? So air is moving toward that center, and because of the Coriolis effect, it's moving around in a counterclockwise direction. Also in the winter, the ITCZ, the intertropical convergence zone, moves south. It's hotter down here in the southern hemisphere in January, and that pushes that intertropical convergence zone to the south. Now if we jump to July, so this is summer in the northern hemisphere, the North American continent and the Asian continent here get really hot. Hot air rises, and that rising hot air creates a low pressure system, which in the northern hemisphere goes counterclockwise. Same thing here, it's going counterclockwise. Also, we still have our Pacific high and our Bermuda high. Those those subtropical highs. The difference is they shift a little to the west, so they both shift westward, and they strengthen, they get stronger, which increases the precipitation to the continents that are to the west. So the eastern part of the U.S. is going to be getting more moisture moving in off the Atlantic Ocean and the Gulf of Mexico, and then this Pacific high is pushing moisture towards Asia. Also, the intertropical convergence zone is going to move northward. So the northward movement of that with these low pressures is what we call the monsoons. And here in the southwest, we experience moisture coming in off of the Gulf of Mexico, which can fuel those afternoon thunderstorms, which actually you might be able to hear the patter of rain on my window right now from a afternoon monsoonal thunderstorm. Same thing here, the Asian monsoons, we get moisture coming in off of the ocean and fueling the monsoons in Asia. So the arrows are surface winds. They move from high pressure to low pressure, but they also are influenced by the Coriolis effect, which creates circulation patterns. In the northern hemisphere, lows circulate counterclockwise, highs circulate clockwise, and it's opposite in the southern hemisphere. Let me know if you have questions.